Today we are going to apply some of the vector stuff that we've been talking about, but first we are going to review bearings and directions. We did this, we talked about this and used this when we did law of cosines, so just need to refresh our memories here, that the direction of a vector can also be given as a bearing, and we usually use beta for the bearing. They are frequently given in application problems, okay? And that's also why we're in degrees, because it just makes more sense with that stuff. All right, so the first thing we have is a quadrant bearing. It's the acute angle between a vector and a north-south line or y-axis. So start with the y-axis, you either go north or south first. This one right here, this is south 60 degrees east, because you go south and then you swing out 60 degrees east. So that is your bearing, your quadrant bearing. We'll say B1. All right, beta 1. Then we have the true bearing. That's the angle measured clockwise from the north to the vector. The true bearing of this goes from here to here. So if this is 60, that makes this 30, which makes this 120. And that's the true bearing. B2. True bearing is written as 3 digits. So if you have a bearing of 15 degrees, it's going to be written as 015. Okay. Sound familiar? Remember doing that? Okay. So let's look at number 1. We're just going to talk about bearings first. We're going to give the quadrant bearing and the true bearing. So it gives me this right here. What it gave me is theta. Because the whole reason we have to figure this out and know how to do it is because when we substitute stuff in, we're using theta. We can't just grab the bearing angles and plop them in there, right? We need to know how to convert back and forth. So as a quadrant bearing, this we would go north and then swing out this way, something east, right? So it's north, something east. And if this is 85 degrees, what's this angle? 5. So this is 5 degrees right here. So we would be north, 5 degrees east. True bearing goes from north and clockwise, so it's the same value, but we would write it as 005 because it's a 3-digit situation. Okay. Any questions about that? All right, so what they gave us here, this is theta. For a quadrant bearing, I would go south and then swing out west. Right, so it's going to be south something west here. I know that from here to here, so from the positive x-axis to the negative x-axis, that's 180. So to find this part, I can do 212 minus 180. That gives me 32 degrees. So now that I have that 32 for my quadrant bearing, I would go south, and what would this be? 58. 58 degrees west. Yes, you always go either up or down first and then swing left or right. Okay, so the first letter will always be an N or an S, the second one will always be east or west. Okay, on number 3, did they give us theta? No, they did not. But we need a quadrant bearing first, so I would go north, since it's up here, and I'm going to swing out that way. So that would be north 24 degrees west. So even though they didn't give me theta, I can still figure out my quadrant bearing based on the angle that I have. True bearing, oh, I didn't do the true bearing on this one. Well, let's finish number 3 and I'll go back to number 2, sorry. We're going to start here. We're going to go all the way around. So we almost went 360, right? We just didn't make it 24 degrees. So if I do 360 minus 24, then I'll be good. What is that? 336. Okay, now let me go back and finish number 2. The true bearing would start here and go all the way around to here. So what could I do to figure that out? (180 plus 58) The other ones I heard, I'm not sure if they were right. But if from here to here is 180, and then I'm just going to add 58. I could do 270 and subtract 32. Either way, it doesn't really matter. But what would this give me? $238. Okay. It's a good idea to actually draw a little picture and put the little arcs on there so you can visualize it and know what you're adding and subtracting and whatever. Okay? What questions do we have? We good? All right, so let's look at number 4. It says an airplane is flying at a bearing of 245 degrees. So that's my beta, not my theta. Okay, at 550 miles per hour. We're going to give the velocity of the airplane as a vector in component form. So the first thing I want to do is figure out what my theta is. So there's my little x and y axis here. I have a bearing of 245 degrees. So I start here. That would be, it's going to be between going 180 and 270. So it's somewhere over here. This right here is 245 degrees. What I want is theta. Theta starts at 0 here, just like it always has, and it goes around this way. So it's 180 plus a little bit. So I'd like to know what that little bit is. Well, here on my bearing, this was 180, this would be 270. So if I do 270 minus 245, then I'll get this piece right here. What would that be? 25. So this piece is 25 degrees. Then what do I do with 25 to get theta? Add it to 180. So theta is 205 degrees. That's the angle that I would actually use. All right, so now I'll find my vector. My magnitude is 550 miles per hour times the cosine of 205, and then 550 times the sine of 205. Go ahead and type those in. That vector is negative, negative. Does that make sense from our little picture? Mm-hmm. So it's a good way to kind of check yourself on that. Okay. Everybody good on that? Mm-hmm. Because that's it gives you the angle and the magnitude. All right, let's look at number 5. So a man pushes a lawnmower with a force of 25 pounds uphill at an angle of 40 degrees. Give the force exerted on the lawnmower as a vector in component form. All right, so if he's going uphill, here's uphill at an angle of 40 degrees, then that is my theta, right? If you're going uphill, you're with the horizontal, and there you go, you got your 40 degrees. So this one's pretty simple. Because sometimes you're just given theta. My vector is, so my force or my magnitude is the 25 pounds. So 25 times the cosine of 40, and then 25 times the sine of 40. I'll just give y'all what these are. I know you can type that stuff in, so I'm not worried about it. And then 16.070. And that's what you would get. So as long as you've been typing them in and getting the right things, you can just copy those down for me right now. It's fine. Okay. So now we have a cruise ship that is sailing at 20 knots in the direction of north 12 degrees west, and we want to give the velocity of the cruise ship as a linear combination. Okay, so I'm going to go north 12 degrees west. So I'm right here. This is 12 degrees. That is definitely not theta. What do I do with the 12 degrees to get theta? No, that would give me that true bearing if I subtracted it from 360. What I want is starting from here. So I would just add 90, right? Because I'm trying to get theta. So now that I have that, got 20 times the cosine of 102, 20 times the sine of 102. So that gives me negative 4.158 and a positive 19.563. So am I done? No, why not? Yeah, it says linear combination of vectors I and j. So my actual answer is negative 4.158 I hat plus 19.563 j hat. And that's your answer in the correct form. What questions do you have? All right, so now we're going to have a resultant force, meaning that we're going to have more than one vector. So if two or more forces are acting upon an object, then the resultant force is the sum of the two vector forces. So here we have two tugboats that are pushing a barge. If tugboat A is traveling in the direction, so I've got tugboat A traveling in the direction of south 80 degrees east. So let's take care of that angle first. So tugboat A is going south 80 degrees east. So this is 80 degrees right here. And this is for tugboat A, say for vector A. What do I do with that 80 to get theta, which is this right here? Add 270, good. So 270 plus 80 is 350. Then I have to deal with B here. So tugboat B is traveling in the direction of north 65 degrees east. So I'm going to go north 65 degrees east. It's like right here. This is 65. So this is tugboat B, or vector B. What do I do with 65 to find theta? Subtract from 90, good, and that will give me 25 degrees, right? Okay, so let's think about what's happening here. We have vector A that looks kind of like this, but that's probably not the right angle. Not the correct angle anyway, but it'll be close enough. And then this is vector B, and we are adding them together. So this is A, this is B, this is A plus B. Okay? And it looks to me, although I know my angles are not really correct, my pictures are not to scale at all. It was just kind of something to label. But it looks like it's probably going to be pointing to the first quadrant. Definitely possible my angles are way off and it's pointing to the fourth quadrant, but I'm pretty confident it wouldn't be a second or third. You with me on that? So we can kind of think about reasonableness. All right, so let's set up vector A. So vector A, oh, I didn't continue reading the problem. It says both boats are pushing with a force of 400 pounds. And we're going to find the magnitude and direction as a quadrant bearing of the resultant force. So we've got 400 pounds times the cosine of 350, and then 400 times the sine of 350. Okay. Then I'm not typing anything in yet. We're going to do B. B is 400, because they have the same force, times the cosine of this 25, and then 400 times the sine of 25. So we're going to add these together. We added them together visually over there. We're going to add them together here, which means I'm going to add the two x components, I'm going to add the two y components, and we're going to store it on our calculators. So look at your calculator. Again, make sure it's in degree mode. So when we had been storing, we'd been hitting shift, recall, right parenthesis to get that x. But let's use a and b instead. Not because these are vectors a and b, but just because we use a, b for, the other vector stuff. So right above recall is the negative sign. You see the red a and b. Let's use that since we're going to store more than one thing. So you're going to type into your calculator 400 times the cosine of 350, close your parentheses, plus 400 times the cosine of 25, hit equals. You should get 756.446, and then we're going to store it. You do shift, recall, negative sign, and it should say that your answer was stored in A. We good? Okay, so then we're going to do the same thing for the y component. We'll do 400 times the sine of 350, close your parentheses, plus 400 times the sine of 25. You should get 99.588. Then we're going to store that in B, so shift, recall, all those comma things for B. All right, everybody good? And this is positive, positive, so it is pointing towards the first quadrant, so my picture wasn't too terribly bad. It got me the right idea there. So there's my vector and component form, but that's not what it's asking me. It's asking me for the magnitude and the direction. So I've got to find the magnitude of my resultant vector here. So the magnitude of A plus B is, so the way we found the magnitude is it's the square root of A squared plus B squared. So that's literally what you're doing in your calculator. You're going to do square root and then recall A squared plus recall B squared. And you should get 762.973. And then this is pounds. So when you type this into formative, you're going to leave off the units just because that makes it a pain sometimes. But in your work and stuff, make sure you have them. That's still very important. Okay? Are we all good with the magnitude? Any questions? All right, so now we got to find theta. Theta is the tangent inverse of B over A. And so we can literally do that in the calculator. And this is a first quadrant vector. So the calculator gives me alpha, and that will be my actual angle here. Although it does say quadrant bearing, but it will be my theta. That's what we need to worry about. So let's do tangent inverse of recall B divided by recall A. You get 15 over 2. We're just going to make that 7.5. Now I got to think about it as a quadrant bearing, like it says. So my 7.5 degree angle is about right here. So my bearing, it's going to be north something east, right? How do I figure out what that something is? Subtract this from what? 90. Good, so it'll be 82.5 here. So my bearing will be north 82.5 degrees east. And when you type in the bearings, if you're doing a bearing like this, leave off the degree sign when you type it in. And this is all smushed together. There's no spaces. Just cram it all together. Okay, everybody okay with that? Questions? All right. Let's look at number 8. So this says two forces with magnitudes of 85 pounds and So we have 85 and 120 pounds are acting on an object at angles of 35 and 140 respectively with the positive x-axis. That's great. If it's with the positive x-axis, that is theta. So we don't have to figure out what theta is. They gave them to us. Okay, so we're going to find the magnitude and direction to the positive x-axis, which again means theta, okay, of the resultant force. So now I just have to set this up. So I have my first vector, which will do, the magnitude is 85 pounds. That's going to be times the cosine of 35. And then 85 times the sine of 35. Vector 2, my magnitude is 120 times the cosine of the other angle, which is 140, and then 120 times the sine of 140. And be careful when you're writing these out, because more than one time when I was making the key, because I was going fast and not paying attention, I did like 85 cosine 35, 120 sine of 140, and then I caught myself, but I kept having to erase. So in your vector, the only difference between the x component and y component should be cosine and sine. The magnitudes and the angles should match within the same vector. Make sense? Okay. So now we're going to find vector 1 plus vector 2. So that means, again, we're going to add them together and store them in A and B. I mean, you can store them anywhere you want. Just A and B makes sense to me since that's what we've been using for these. So go ahead and do that on your own. Oops. How do you store it, or how do you recall it? How do you sort it down? Okay, so type it in first. Okay, so now do shift, recall, and then A. Uh-huh. No, not alpha. No alphas. There you go. Intelligence and A. So that's what you should get. Make sure you have them and they're both stored so you can get through the rest of this. Okay, we all have our new vector. So now we're going to find the magnitude of vector 1 plus vector 2. That's going to be equal to the square root of a squared plus b squared. And if you have them stored correctly, that's all you got to do to get your answer. And you should get 127.848 pounds. Everybody good? Any questions? Okay, so then we're going to have to find theta, and in the end it's theta. We don't have to do anything with the bearing there. So theta is the tangent inverse of b over a. And what quadrant are we doing? This is quadrant 2. Okay, so that means we're going to need to find alpha before we find theta. Now go ahead and type that in and tell me what happens. It's negative, right? Okay, so we haven't gotten the negative angles before because I've told you when you type this in, always use the positive numbers. But we have stored numbers, so we don't want to have to go mess with that. Just, if you get a negative angle out, that's not alpha. The positive version of that is alpha. So what I would do in my calculator is do times -1 to make it positive. Like, don't retype it in, just multiply it by -1. So your alpha is, where am I, 79.956 degrees. So that's my first quadrant angle, but I need it to be in the second quadrant. So what do I do with this to get my second quadrant angle? Subtract it from 180, and so that'll give me 100.044 degrees. So you could have left it negative and just added 180, but I think it's better most of the time just to be consistent. Make it positive, do the same thing you've been doing on all of the rest of them, and you won't get it all mixed up. Okay? What questions do you have? Yes, sir. Right, because on this one it told us to. It said find it as a quadrant bearing. Here it said to find it relative to the positive x-axis. Okay, so you have to do whatever it says to do there. Okay. We good? All right, so on number 9, we're not going to do the whole thing. We're just going to find the angles. So we have 2 cranes are lifting up a statue. And so here's my x and y axis. And so here's my statue. It's a really skinny statue. And crane A is pulling with a force of 600 pounds at an angle of 35 degrees to the left of the statue. So this angle right here is 35. So it's not a theta, it's not a bearing, it's not anything, it's just an angle with the statue. Then the crane B is pulling with a force of 750 pounds at an angle of 50 degrees to the right of the statue. So this is 50 degrees. Let's see, this was B, and this was A. Okay. So the theta for A, what do I do with that 35 to get theta? Add 90, so this would be 125 degrees. And then theta for B, what would I do with that 50? Subtract it from 90, and that would give you 40 degrees. Okay? Does that make sense? And then those are the angles you use in your vectors. Right? Any questions at all? Oh, I did forget to say one thing I wanted to say. So informative, I told you to leave off the units and stuff, but there's going to be 2 answers for these questions, and I can't put 2 answer blanks, or I can't figure out how to put 2 answer blanks anyway, on there. So what you're going to do is if you were typing this one in, you would put 127.848, comma, space, 100.044. Okay? So just put the magnitude, comma, the angle, and it should work out just fine. There's no brackets or anything because it's not a vector. You're just having to put in 2 answers. Okay? We good with that? Any questions at all? What's your question? You don't have a question? Okay.